Okay, the next type of limit that we want to look at are limits at infinity and how we go about evaluating these algebraically. And this procedure is very simple and very straightforward. Again, remember that these are the same as horizontal asymptotes when they do exist. And the first thing we're going to look for is the degree of the leading term in each expression. So for example, you see number 19, the leading term here. In the numerator, it's 2x. In the denominator, it's 3x. Whenever we have the degree, or the degree is first, it's the first degree because x is the first power in both the numerator and denominator. Whenever we have the same degree in the numerator and denominator, the limit as x approaches infinity, and this only works when x is approaching infinity, is going to be the ratio of the leading coefficients. And so that's just 2/3 there. Now the same thing works with number 20. We have 3x to the third over 9x to the third. The degree, it's a third degree polynomial in the numerator and denominator. We're just going to take the limit. We're going to take the ratio of the leading coefficients, which is 3 over 9, simplified to 1 over 3. Now for number 21, the second type of problem that we could have is where the degree of the numerator is less than the degree of the denominator. The degree of the denominator is larger and it's going to grow faster as x approaches infinity, and so it's going to outpace the numerator, and what's going to happen is the ratio is going to become 0. So whenever the degree of the denominator is larger than the degree of the numerator, the limit as x goes to infinity is always 0. So let's see if there are other ones like that out there. Um, Now, in number 22, we have again the degree of the numerator is x to the 0 power, which is 1. The degree of the denominator is x to the first power. So that limit of 3 over x will become 0, but the 4 stays 4. So that limit is 4. Number 23, as x goes to negative infinity. Now you have to take care of the negative sign here. The numerator will be positive. This is a case where the degree of the numerator is larger than the degree of the denominator. And so it's not going to have a horizontal asymptote there. We can talk about the direction. When x is a large negative number, the denominator will be negative. The numerator, because it's squared, will always be positive, so that answer will be negative infinity. In the next problem, because you have some different things happening there, what I would suggest is maybe to find a common denominator, which would be x squared, or 2x squared. And so we would multiply the left side by x squared over x squared. And so the numerator will be x to the third power. The second term we're going to multiply by 2 over 2, and what we're going to get there is 8. And the denominator will be 2x to the second power. So this is an example of where the degree of the numerator is larger than the degree of the denominator, and so this value will go to infinity. It will not have a horizontal asymptote. Can we tell something about the direction? X is going to negative infinity, so it's a large negative number. X to the third will keep that as a negative number, so the numerator will be negative. The denominator, because it's squared, will be positive, and so that will go to negative infinity. Now the next four problems are all similar. You have x in the numerator and you have square root of x squared. It only works when it's this way. You have a first degree in the numerator, then you have a square root of a second degree in the denominator. And I'm not going to go through this example, but this is one of the examples where you remember that the square root of x squared is x. But actually it's plus or minus x. So it could be when x is positive, it'll be positive. When x is negative, it'll be negative. Sorry, the limit will be negative when x goes to infinity because the numerator will be negative in that case. The denominator will always be positive because we're squaring and then taking the square root. So the first one will be negative 1, and the next one will be negative 1. The third will be negative 2, and the fourth, because the negative 3 times a large negative number will give you a positive number, will become positive 3. Note they will be different as x goes to positive and negative infinity. Those answers only apply here.